Welcome. Now, I'll be talking about the science behind time travel. In science fiction stories, time travel is some of my favorite stuff, but just how much of this is really grounded in reality? And what's the science behind it? I'll even give you real-life examples. And before I get started, I wanted to list my qualifications. First, I've done a few internships at NASA Langley. Second, and most importantly, I've watched every Kurzgesagt video. So I think I know a thing or two about a thing or two. First, let's talk about time. Einstein here will explain his theory of relativity.
Time is not absolute. It's relative, meaning it flows differently depending on your speed and gravitational field. This is called time dilation.
Wow, thank you, Albert Einstein head. I accidentally cut in half before realizing I had to re-record. This means if you were traveling at a significant percentage of the speed of light for a long period of time, your clock will actually be going slower than those, say, just chilling on Earth. Essentially, you're going to the future. Let's do a little thought experiment. I'm sure you've heard of the twin paradox, where you have a set of twins, you grab one of them, probably a baby crying on a plane, and you throw it into a rocket, and you send it off. Well, if it's going 99% the speed of light for a while, and it comes back, the other twin who stayed on Earth will be older than the one who was in the rocket. So, do we have real examples of this? Unfortunately not. We have to deal with those babies. But the closest we can get to that is astronauts aboard the International Space Station. The people up there are the only ones who go really fast for a long time. They actually go around 28,000 kilometers per hour, or in freedom units, 17,500 miles per hour. That means that the astronaut who spent the longest time in space, 803 days, would have traveled It ain't much, but it's honest work. Now, that was all about how going really fast can have time dilation effects. But Einstein here also mentioned something about gravity. Well, I'm sure you've all seen, hopefully, the movie Interstellar, because it's a great example of this. Gravitational time dilation happens when an object is in a strong gravitational force, so strong that it actually warps space-time. We see this in the movie when Gargantua, the black hole, is so strong that the planets around it, 1 hour on those planets translates to 7 years back on Earth. As we established earlier, this just means that your clock is going much slower on this planet because of the gravity compared to lesser gravity, which is on Earth. So you're essentially going to the future. A surprise, I know. We never really sent a human to a black hole and back for me to say a real-life human example. We know that atomic clocks at differing altitudes, and thus different gravitational potentials, will eventually show different times. So we can see that time dilation does occur even on smaller gravitational fields. Now, you may be saying, Ethan, wait! We've certainly talked a lot about time traveling to the future, but time travel stories are usually about going to the past. That's where all the fun stuff happens. What about that? Science doesn't like that. In the realm of theoretical physics, time traveling to the past is usually explored through things like wormholes, and wormholes need exotic matter with negative energy density to stabilize and have the conditions right to stay open and maybe work. As I said before, this is all speculative. Nobody really knows much about this. And even if wormholes could exist, practical or stable time travel through them is a pretty far reach because of energy and causality constraints. What I mean by this is that it probably takes too much energy to keep the portal open, and causality just means that the universe is probably built in a way that it doesn't want you to do that. It won't let you go back and change stuff. As we can all imagine, I can make 5 more minutes of this video just going over all the wacky no-nos that happen if you go back in time. Let's not do that. That's a pretty big bummer, I know. But there is a way that I think anybody can experience time travel to the past, and it's by looking up at the night sky. When you look in the sky and you see a whole bunch of cool stuff, you have to remember that that stuff is really far away. So far away that it takes light forever to get here. Our closest galaxy is 2.5 million light years away. When you look up in the sky and you see the Andromeda Galaxy, that's how it was 2.5 million years ago. That's not how it looks anymore. Even the sun is 8 light minutes away. When you look in the sky and you see it, that's how it was 8 minutes ago. If that's not time travel to the past, I don't know, man. That's the closest you're gonna get, probably. Well, thanks for listening to my presentation. Hopefully you learned something, and yeah.